So let's talk about what's inside the tool. And I'm going to start in the middle with the brains of the tool. This is the part that in previous times and in previous tools would have been duplicated in MWD and RSS. We put it all together. And in the center of the tool, we've got sensors that tell us where the bit is, what direction it's pointing in, the inclination and azimuth of the well. There'll be other sensors in there that might give us other information that helps us to manage tool face of our rotary steerable system. And in time, we will also be adding logging sensors, and we'll be able to tell you about drilling dynamics and drilling mechanics. And all of that will be derived in this section of the tool, which has got sensors, memory, A to D conversion, and processing. And then we get that information from the tool to the surface, and we also use that information to steer the drill bit. Let's look at what happens closer to the surface. If I move slightly uphole from the sensors and the electronics, there's a section of the tool here which provides the power. In Pandora210, that power is likely to come from a battery. In higher temperature versions, it will come from a turbine generator. Drilling mud flowing from the surface will drive a spinning turbine, which will drive a generator, and which will produce the electrical power that the tool needs. And in this section between the sensors and the processors and the generator, there'll be the rectification and the regulation that's required to manage the electrical power. Also in that section, there will be the control that we need to drive a brushless DC motor, which is at the upper end of the tool. That motor will sit above the power generation, and that motor will drive a valve, which in turn will be a pilot valve that drives a mud pulser, and the mud pulser sits right at the top of the tool. The function of the mud pulser is to generate pressure pulses in the drilling mud as it comes down the well, and use those pressure pulses to communicate with the surface in just the way that a mud pulser works in a conventional oil and gas MWD tool. The point here is that we use a pilot valve to drive the mud pulser, and we have motor control for that. Now I'm going to step down towards the bottom of the tool, and as I step down to the bottom of the tool, there's another brushless DC motor that drives another valve. And this valve controls fluid flow to pistons and therefore pads on the steering head. And as far as possible, the motor at the bottom of the tool that drives the rotary steerable valve and the motor at the top of the tool that drives the pulser are going to be similar. They might even be the same. They'll be very, very close to each other. And again, that helps us to reduce the amount of engineering and development risk that we have in the tool. The valve at the bottom of the tool controls mud that goes to one of 3 sets of pistons. And that mud, when those pistons are activated, opens steering pads that will push the bit sideways. All of the modern, successful rotary steerable steering heads use a very similar principle with a single rotating shaft with a valve on it that distributes fluid to multiple pads. And we're going to do exactly the same thing. It's very well proven in the industry. Those pads will provide steering force, which will allow us to control the final element of this puzzle, which is the drill bit right here, and allow the drill bit to be steered and produce a perfectly true lateral or directional section, place the well in exactly the right place, so that for EGS we can drill pairs which are perfectly parallel to each other and exactly the right distance apart. For AGS we can drill wells that maybe will even meet at the toe of the horizontal. We can minimize tortuosity, maximize wellbore quality, and thereby maximize the horizontal or the directional length and maximize the amount of production from the well.